All right, 4.10 is applications and sinusoidal curve fitting. So it says we've discovered several characteristics of trigonometric functions written in standard form. Let's summarize here using the sine function. Describe and explain the changes to the graph for each value in the equation below. Example 1 says given the standard form of a sine function, y equals a sine of bx minus c plus d. Complete the summary in the table below. All right, so amplitude. Remember, amplitude is the absolute value of A. So it's our A. And so we just says absolute value of A. If we're given an equation, remember if we're given a graph or some data, it would be maximum minus the minimum divided by 2. All right, and the effect of this is if it's tangent or one of them that doesn't actually have an amplitude, this is actually just going to be your vertical stretch or compression. And amplitude is also the distance from the midline to the maximum or the minimum. It is half of the height of the curve. For the period, remember that our period is 2 pi over b. And so that's going to help us find the b value. Remember, the period is the length of one full cycle of the wave. It's how long it takes the graph to repeat itself. Okay, the phase shift. Remember, the phase shift was c over b. And so this is that horizontal shift of the first point. And so I'm going to write the first key point, because that's that first point in our table, okay? So it's going to affect that y value. That x value in that table. The very first one, though. And your vertical shift is your D. Remember, that's also called your midline. This is how far it's the vertical shift. To find it, remember, we can take our maximum and we can subtract out our amplitude. All right, so then it says, which expression in the table would change if the function was tangent or cotangent? Well, remember, that would be the period. Now, of course, we don't call it amplitude when we're talking about cotangent and tangent or the other reciprocal functions, but we still have an A value. We still have that vertical stretch, but our period would change. Remember, if it's tangent or cotangent, our period is pi over b. All right, and we're going to skip through the next section. And so let's go ahead and go to example 3 here, where it says to find the amplitude, the period, and the phase shift for that equation there. All right, so our amplitude, remember, is the absolute value of A, which in this case would be the absolute value of 2, which is 2. Our period, remember, is 2 pi over b. So this would be 2 pi over, our b value is 2, simplify it, and we just get pi. And then our phase shift, remember, it's going to be that c over b. So when we look at this, c is a positive 3 pi, but remember, because it's inside, it's going to do the opposite. So it's going to be a negative 3 pi over b, which would be our 2. And so we have negative 3 pi over 2, which is the same thing as saying we're going to go to the left, 3 pi over 2. All right, so when I go to graph this, I got to remember my cosine, because that's our function here, cosine parent table. Cosine starts at the top, and then it comes down. All right, but for our transformation, well, our y's, we're going to multiply them by that 2 at the front. And then our x's, remember, we're going to take that 2x plus 3 pi, and we're going to do the opposite to everything. So we're not going to multiply by 2, we're going to divide by 2. We're not going to add 3 pi, we're going to subtract 3 pi. And we're not going to follow PEMDAS because everything does the opposite. So we're actually going to take x, we're going to subtract the 3 pi, and then we're going to divide everything by 2. Now, because we are dealing with fractions, remember, that means we could take x minus 3 pi, and then we could multiply all of that by 1/2. All right, so I'm going to switch over to a blank document, I think, real quick here so that I can show some work. All right, so when I do this, I am going to get rid of this section here, which means it'll be gone when we go back to the other page. Uh-oh, sorry about that. I'm going to get rid of that. All right, so we're going to take that first x, which was 0. We're going to, what do we say, subtract 3 pi, which is a negative 3 pi. And then we could say we're going to multiply that by the 1/2, which gives us a negative 3 pi over 2. Right there, guys, check it. Was that your phase shift? If so, your formula is good that you're using up here. If you don't get the phase shift right there, that first point, your formula is not good, okay? All right, so we're good there. So then we're going to take pi over 2 minus 3 pi. That's what, a negative 2.5 pi, so it's negative 5 pi over 2 times 1/2. That's negative 5 pi over 4. Pi minus 3 pi, it's negative 2 pi times 1/2. That's a negative pi. 3 pi over 2 minus 3 pi is a negative 3 pi over 2 times 1/2 is a negative 3 pi over 4. And then 2 pi minus 3 pi is a negative pi times 1/2. It's negative pi over 2. Now, guys, remember, all of these points should be in numerical order, okay? They may be increasing, they may be decreasing, but they should be in numerical order. One of these will be the largest number, and one of them will be the smallest, and they'll go in numerical order from one to the other. They also should have even spacing. So if you need to, think about them in terms of decimals. Even if they're decimals that aren't exact, you can approximate them, and you should see that they are the same distance between each other. Now remember, if you approximate the decimals, you might be off just a little, but you'll see that they're steadily approximately the same, okay? So if I do the negative 3 pi over 2, that's like negative 1.5 pi. Negative 5 pi over 4 is like negative 1.25 pi. So it increased by a 0.25. Negative 1 pi was just negative 1 pi. Again, increased by 0.25. Negative 3/4 pi is negative 0.75 pi. Again, increased by the 0.25. And then negative pi over 2 is negative 0.5 pi. Again, it increased by 0.25 pi. So our x's are probably pretty good. Our initial one was that phase shift, and they're all increasing by the same amount. And so we have our x's there. We said it was negative 3 pi over 2, negative 5 pi over 4, negative pi, negative 3, let me try this again, negative 3 pi over 4, and then negative pi over 2. Now for our y's, we're just going to multiply them by 2. So we got 1 times 2, 0 times 2, negative 1 times 2, 0 times 2, and 1 times 2. All right, and so there are the points that we are going to graph. So I'm going to erase this middle part where I did this work. So we can go back to our other sheet now. Well, let's see. I'm trying to remember how to... Well, I don't know if I can go back to the other one then. All right. So I'll tell you what. We're going to graph this. So let me rewrite that table. So it's negative 3 pi over 2, negative 5 pi over 4, negative pi, negative 3 pi over 4, and negative pi over 2. And if I remember right, we said it was 2, 0, negative 2, 0, and positive 2. Okay, now watch your scale. All right, if nothing else, guys, I know y'all have trouble with this. Find your 0, find your pi. Find out how many boxes are in between the two. There's 4 on this one. That means each of these lines is a pi divided by 4, okay? So that means this first line would be 1 pi over 4. The second line would be 2 pi over 4, which does reduce the pi over 2. Then we have 3 pi over 4, and we have 4 pi over 4, which does reduce the pi. All right, then 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So that way you know how much each line is. All right, so when you go to graph this, let's see, we have what, a negative 3 pi over 2, and it's up at positive 2. And then it says negative 5 pi over 4. Well, if I'm not sure where that is, I know where negative pi is. And so I could graph that. And I know negative 5 pi over 4 has to be halfway between them. Now, I could have also said, since we said each one's a pi over 4, this is negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, and that would be negative 5 pi over 4, okay? So either way works to find that point. Now, if you notice here, each one of these is going over one line to get to the next one. So if what we've done is correct so far, that means that negative 3 pi over 4 is going to be on that next line to the right. And it is, because if you count, it's negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4. And then negative pi over 2 is back up at 2. And so here is one complete period of our function. And we could just continue our pattern here if we wanted to go all the way across the graph. Or we could go the other way even. Oops, I didn't go far enough. See how, let me point that out real quick since I made that mistake. Do you notice how, like when I just drew this here, all of my minimums are not at the same place? That means there's something wrong. All of the points on the top should be lined up. All the points at the bottom should be lined up, okay? I can see there that mine are not. That means I've made a mistake. What it is, I just didn't go down far enough. But watch for little things like that. That'll tell you if your graph is correct or not. All right, so there's our example 3. So now moving on then, let's go to example 4. It says, given the equation y equals negative 2, sine of 3x minus 6 pi, describe the transformations that occur from the parent graph y equals sine of x, and then sketch the graph. All right, well, we see that there's a negative there, so we know that a negative is going to reflect our graph across the x-axis. So I'm going to write that down first. I also see the 2, which that means that the amplitude is equal to 2, which also means we're going to have a vertical stretch by 2. All right, so then I see that 3x minus 6 pi. The 3 helps tell us what the period is, so that means our period, remember, is 2 pi over the b, which in this case is 3, so our period is just 2 pi over 3. And then c and b help us find our phase shift. So our phase shift is going to be, let's see, it's a negative 6 pi, so that means it's going to be a positive 6 pi over b was 3, which means my phase shift is 2 pi, which means we're going to go to the right 2 pi for our first point in our table, okay? Only the first point. All right, so now we're looking at sine. So we need to go get our sine parent table. And our x's here, our y's here start in the middle, and then it goes up. Now when I go to do my transformation table, I can look at it here and it tells me that my y's are going to be multiplied by that -2 at the beginning. Okay, now the x's is going to be what's in here. Remember, we do the opposite including PEMDAS. So that means that we're going to take, okay, sorry, I had to pause the video there for a minute, so I'm not exactly sure what the very last thing I said was, but I know we were talking about the 3x minus 6 pi when we're dealing with our x's here, and so remember we do everything with x backwards. So that means we're going to take our x, we're actually going to add 6 pi to it, and then we would divide it by the 3. Which means it's the same thing as saying the x plus the 6 pi, and then multiply it by the reciprocal of 3, which is just the 1/3. Alright, so to give us room, I'm going to do like I did on the last one. I'm going to pull up a blank sheet of paper. And let me erase the middle part here. And so we're going to take all of these x's, we're going to add 6 pi, and then multiply by 1/3. So my first x was 0 plus 6 pi times 1/3 is 2 pi. Now remember that first point, check. Was that your phase shift? Yes, it was. Alright, then we're going to take pi over 2 plus 6 pi, which is 13 pi over 2 times 1/3, which is 13 pi over 6. We'll take pi plus 6 pi, which is 7 pi, times 1/3. And so we get 7 pi over 3. 3 pi over 2 plus 6 pi gives us 15 pi over 2 times 1/3 gives us 15 pi over 6. And then 2 pi plus 6 pi is 8 pi times 1/3 gives us 8 pi over 3. Oops, I didn't keep writing them down. So 13 pi over 6, 7 pi over 3, 15 pi over 6, and 8 pi over 3. And I really ought to check and make sure that those are even increments. So I'm going to change these to decimals. So this would just be 2 pi. All right, then we have 13 over 6, which is like 2.17. So it's 1.67, let's say, pi. Then we have 7 over 3, which is 2.333 pi. We have 15 over 6, which is 2.5. That could have reduced actually. 2.5 pi. So we could have said that was 5 pi over 2. I didn't catch that one. And then we got 8 divided by 3, which is 2.667 pi. Alright, and so we can see that they're increasing, and they are increasing by the same. They're each increasing by approximately 0.167. Okay, so we're good on that. Now our y's, we said we're going to multiply by -2. So 0 times negative, I'm sorry. Yes, the first one was 0 times -2, which is 0. 1 times -2, 0 times -2, -1 times -2, and 0 times -2. And so there's the table that we're going to graph. The only problem is when we go to look at our graph only goes from about -2 pi to +2 pi. So that means that I need to, these are too big. They're not on my graph. If I look at my graph, let me see if I can switch over here to just some graph paper at least. Okay, when I go to look at my graph here, you'll see that, is it every 3 lines is a pi over 2? I should have been pi over 2, pi. Uh-oh. And then it actually only has the 2 lines after that, so we'd have to go off a line to actually get to our 2 pi, okay? And then the same thing going the other way. It's 3 lines, not 2. Okay. So, excuse me. So the thing is that my points are too big. So I've got to figure out how am I going to get those points on here. Well, remember that when you graph this, you're going to graph, well, this is a sine. So you're going to graph a full period, right? So how can I make this point be the same as that point? Well, it's a full period, so I could go back a full period, which in this case, remember we said over there on the side, number 3 there said our period was 2 pi over 3. So if we take all of these points and we subtract 2 pi over 3, we should be able to get a point that is on our table or just barely off of our table. So I'm going to take each of these points that we had and I'm going to subtract 2 pi over 3. Alright, so my first point was 2 pi. So I'm going to take 2 pi minus 2 pi over 3. See, that's what, 4 pi over 3? I'm going to take, our next point was 13 pi over 6. I'm going to subtract 2 pi over 3. And I should get 9 pi over 6, which reduces to, is it 3 pi over 2? Yes. Let me double check my math. Yes. All right. My next point was 7 pi over 3. So I'm going to subtract 2 pi over 3, which gives me 5 pi over 3. My next one we said was 5 pi over 2 when we reduced it, minus the 2 pi over 3. So that's 11 pi over 6. And then my last point was 8 pi over 3 minus the 2 pi over 3, which is 6 pi over 3, which is at 2 pi. And we should know, remember we said our first point and our last point are a full period from each other. We also said they have the same y values, so therefore we can see that it did literally just shift it over a full period. Alright, so we should be able to graph those points. So I'm going to take, and I'm just, well, our table's kind of messy here. Kind of clean my table up a little bit, hopefully. And so we can see that we had 4 pi over 3. Then it was 3 pi over 2. And then it was 5 pi over 3. Then our next one was 11 pi over 6. And the very last one there is 2 pi. Alright. Now when we go to graph these, remember you need to know how much each line is worth. So here's 0, here's pi, 1, 2, 3, 4, 5, 6. Each line then is a pi over 6. Well, 4 pi over 3 is the same as 8 pi over 6. So I'm going to go over 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. There's the line I'm first going to start on. Alright, so, and it's at 0. 3 pi over 2 is right there. It's at negative 2. Now notice they're one line apart. So I'm pretty sure the next one's going to be this line, but we can check. 5 pi over 3 is 10 pi over 6, which that's 10 lines from 0. Be careful. Look at that 2 pi goes to the graph, okay? 11 pi over 6 is at 2. And then 2 pi is going to be at 0. And so you will have to go off your graph like one line to hit that 2 pi. But that's okay. You can do it. And then we can just continue our pattern. And just keep going. Oh, not a good idea. I should draw my points. I knew that was going to happen if I tried it. Make sure your spacing is the same. Make sure that all your maximums are the same y value, all your minimums are the same y value. And there is our graph. Alright, so continuing on, we're going to skip over the summary here. And let's just go into this. So it says finding the sinusoidal functions from the data. The table below shows the average temperature per month for Atlanta, Georgia. Information was found at the World Climate website, and it gives you the information there. So the first 5A says we're going to plot the data below and notice that they approximate sinusoidal behavior. Sinusoidal behavior means it's going to have that curve, that wave that sine and cosine are going to have. All right, so we're going to plot all of these points. And let's see. Look at my points here. So we're going to let January be month 1. And I'm just going to kind of skip a few of them here because I'm almost out of time. But think about while you're doing this, what you know about temperature, okay? You know that temperature is cyclic. You know that every January it's going to be approximately the same type of temperature, and every June and July and August it's going to be really hot, about the same temperature. All right? So knowing that, we know that it is repetitive. It's going to have this cycle that's going to repeat. And so when I graph this, it should look like this, and I expect that it would just keep going about the same, okay? So go ahead and make sure you plot all your points there, and then let's go on and let's look at the questions on the next page. Now I'm just going to move my thing up here so we can still see our data points while we are doing this. All right, so it says, the first question on the back there where you're at says, why does it make sense that the average monthly temperatures can be modeled by a periodic function? Is because average monthly temperatures usually don't vary by much, and they'll repeat about the same from year to year. All right, then 5b says let's model this graph with the sine function in the form of y equals a sine of bx minus c plus d. Use your data plot to estimate the amplitude, period, vertical and horizontal translations. Use these values in the sinusoidal equation and test your model by using your calculator to graph it on top of the data.